Good everyone, and you are welcome back to another episode of our training. In this training, we are going to run the analysis and design of this model. Before we go into the training, I want to apologize because for a while now I've not been releasing videos. I've not been consistent with the release of the videos. Please accept my apology. I've been actually busy with some site works. I just hope very soon we come to the end of this training, then we go into something else. So now let's go into the training properly. Let's go to the plan. Before we run the analysis, there is something I noticed here. I noticed that the length of the cantilever slab that we have here, let's go to measure. If you measure from here to this point, I noticed that the length of the cantilever slab we have is quite much, and I wouldn't want to run the analysis like this. I would want to modify this model a little. And if you check this other one as well, you can see we have 3.275. so this length are quite much, and I would like to modify this model a little before we now go into the analysis. So I press escape, then let's modify this model a little. So I'm going to delete the slab here, and the same thing is applicable to this other side. So I'm going to delete this slab. Alright, so now this is how we go. Now this is our opening. I have the architectural plan on my model. Now this is the first floor plan, and this is the opening. So what I'm going to do now is that I'm going to offset an axis. I will place it here just at the edge of the opening. Then I'm going to offset a little backward by pressing the Ctrl F2 on my keyboard. Then I will type -112.5 on my keyboard, enter. What I'm trying to do is that I'm trying to offset the axis to the middle of my column, because I want to have a column around here. Yeah, I think this is fine. So now I can go to model, then go to column, then I can make my column 450 by 225. Then I will make the E1 and E2 00. So let's make this 225 and this one 450, so I can have this. Alright, so now I will do the same thing around there. So I will click on this column, then go to modeling, click on column, then I will have the same thing here. Alright, so now I'm going to model a beam that will be running from here to this column, and possibly another beam running from this column to this column here. So let's select I want to look for a similar beam, 225 by maybe 750. Then modeling beam. So I'm going to run the beam from the center here to this point. So I want to run another beam from here to this point. Then I want to have one here to this point. and to this point. So I can have from here to this point. So now I have my opening around here, so I can model my slab. Also, I will just select a slab, then go to modeling, select slab, beam region, then I can model my slab back. And close. Alright, now I have my opening here and I have this arrangement here. If you feel this column is not flushing well, is not flushing properly, you can just adjust it. You go to properties and adjust this let's deduct the half of this beam, half of this column is going to be, half of 450 is going to be 225, then 225 minus half of the thickness of the beam. So we have, let's go to calculator. So we have 225 minus the half of the beam is going to be 112.5. So we have 112.5. So now I can make it, let's say 112.5. Let's update and see. Oh, sorry, let's take this back to 0. Let's use this 112.5. So let's make it minus 112.5. Alright, so now the column is flushing well, and this is okay. So now we are going to do the same thing on this other side. We are going to do the same thing on this other side, but in this case I would, instead of okay, let's first of all offset this axis, offset to the end of this opening, then offset again. Let's say Ctrl F2, then 112.5. That's to the center of the column I want to introduce. Alright, so now we can now click okay, let's make use of this modeling column. Then I'm going to place a column right here, and I'm going to place a column right here. Close. So now then again I want to do something here. This reception area, I want to make it a reinforced concrete wall. So what I'm going to do now is that I'm going to offset an axis. I want to take it to the center of this wall, but first of all I will place it here. Then I will now offset downwards. So I press Ctrl F2 on my keyboard and write and type minus 112.5 on my keyboard. That is to the center of the wall. Again here, okay, in this case I don't think there is need for me to offset any houses. I'll just make use of the existing houses here, but for the vertical area I'm going to need an axis, so I will offset this axis. Just look for any vertical axis and offset, place it here. Let's see, the thickness of this wall is 150. Okay, I want to take this to the center, so I want to take this axis to the center, so I will offset by 75. Ctrl F2, so type 75 on the keyboard, enter. So we have this now. So now it's easier for me to model the wall. So I will go to modeling, then wall. The thickness of the wall, I want it to be 225, and the extension will be half of the thickness, that's 112.5, and here again 112.5. I think I've explained this I and J before, so I will just go and model. I will click from here to this point. Okay, product structure is telling me that my wall is intersecting with this beam. So what I'm going to do is I'm going to delete the beam first. Let's delete, then we're going to model again. Alright, so I will go back to the wall, then I will adjust this again to 225, then 112.5 and 112.5. So I'm going to model the wall like this from here to this point, then from here to this. Okay, let's take this one. Alright, so we take it to this point, then from here to this point. Alright, now so we have the wall like this, so I will close this. So now I'm going to model the beam again. So I will click on any beam, then go to modeling and select beam. So I will come back here, then model the beam again. Now product structure is asking me if I want to split the beam at the supporting spans, so I will click no. Close. Why product structure? The reason why product structure asked if I actually wanted to split the beam is because of this point load that is resting on this newly introduced beam. So I think I have a wall load. I have wall load on the beams. So I'm going to click on this existing beam with wall load. I will just copy the wall load, then press the Control key and select this beam. Then I will select this beam as well, then paste copy beam loads. Alright, now I'm going to there is need to model this other wall again. There is need to model another wall here to complete this. So I will click on this wall, then go to modeling, and I will select wall. So I have the same property, so I'll just click here, then to this point, then again I will click from here to this point. Okay, it's telling me my wall is intersecting with the beam, so I should have deleted this. I should have modeled my wall first before the beam. So I will now click on wall, then modeling wall, then from here to this. So I will go back to beam, modeling beam. So from here, alright, close. Oh, there is a problem here. Let's model the beam again. So I will click on beam, modeling beam, from here to this point. I still have this, so let's do it again. Let's delete this beam. So let's do it again, modeling beam, then from here to this point. Beam, modeling, let's delete this one first. Select beam, modeling beam, modeling beam, okay, this is what we are going to do. Let's delete this wall. So let's delete this wall first. So let's model the beam now. Modeling beam, modeling beam, okay, it's better now. So from here again, so let's model the wall. Modeling wall, that's a problem. There's an intersection between the wall and the beam. Alright, what we are going to do is that Let's offset and axis, offset, and let's drop it here. So let's model this wall again from this point to this point. Alright, close. Alright, so now let's transfer the wall load. Copy wall load, press the Ctrl on the keyboard, select the beam and paste the beam load. Alright, so now we have the opening around there. So now let's model our beam. I'm going to copy from this beam here, select this beam, go to modeling, select beam, then I will just draw it like this. Then another one from here. Then another one from here to this point. Alright, so we can have one here. So let's have this here. Alright, so now we can also break this one. So we close this. Now let's model the slab. So let's select one slab, go to modeling, slab, beam region. Okay, it's not showing, so let's use another option. Okay, let's use as a peak point. 1, 2, 3, 4, 5, 6. All right. Okay, so let's go to this area as well. Let's delete this one or this insertion point first. So we start from here. 1, 2, 3, 4, 5, 6. All right. Alright, so now for this area I will use the beam region option. Beam region, click here, and here, then I can close this. So this is my opening. Alright, so what we are going to do now, since we have the same arrangement at the other floors, so what I'm going to do is, first of all, I will go to the other floors and delete the existing slab there. I will delete this slab. I will delete this slab. So I will go to Storey 6 and do the same thing. Then I will go to Storey 8. Then we'll do the same thing. Alright, so now we go back to Storey 2. Then I will generate all the new members I have here to the other stories. So I will select all the members, the columns, the beams that I have here. I'm going to generate them to the other stories since I have the same arrangement. Which one again? Okay, then this one, this one, this one, this one, this one, and then the columns, the beams, Alright, so I'm going to right click, then I will go to generate members to the other stories. So I will select story 4, press the control on your keyboard, story 6, story 8, then I will select story 9 as well. Okay, yes. Alright, so this is completed, and I will close. So let's go and confirm. Let's go to, oh, I didn't generate this column, that's why we have this sign. So we go back to story 2 and generate this column. Generate to story 4, 6, 8, 9. Alright, so we can close this. Alright, so that's fine. So let's go and check what we have done. Story 2, story 4, oh, we didn't generate the slabs, so we go back to story 2 and generate the slabs. This, so this. So we generate all these to story 4, 6, and 8. Alright, so we close this. Oh, we did not generate this wall. Okay, we have the wall here. Alright, now the next thing we are going to do now is that you will notice that the wall here is showing, but it's not like what we have in story 9. The reason is because the walls that we have here, we need to work on the length of the story. Now this is what I mean. Select all the walls by pressing the control key, then you go to properties, sorry, let's do something. Let's go to 3D view. Okay, I think our wall is okay. I think the wall is okay. Yeah. Okay, let's change this. There's a problem with the wall here. The wall here at Storey 9 is intersecting with another wall. Okay, so let's go back to the plan. So now at Storey 9, we select all the walls. Then we go to properties and change the length of story to 1. Alright, so let's have a look in 3D. Alright, so it's no more intersecting. Alright, so this is fine. So we go back to plan. Alright, I think everything is okay now. We go to building settings, then I'm going to switch off the houses so we can see the model clearly. So we go back to 3D. Alright, so let's generate this to Storey 10. So we generate to Storey 10. Yes. Oh no, there is no need of generating this to Storey 10. Sorry, I was thinking it's a lift. So let's delete it again. Yeah, what we have done is okay. What we have done is fine. So we leave it like this. So let's check our model before we now run the analysis. Now another thing before we run the analysis, remember we just generated some beams to the, let's go to plan. We just generated some beams at this Storey. So now those beams do not have the roof loads on them. So I feel we should go to Storey 9. Let's go and edit member load. Okay, so now let's copy again. Let's copy. You will see copy manual load. Then you go to the last beam, press the shift key and select the last beam here. Right click, then paste copy beam loads. Yes, so that the new beams we generated, we also have the roof loads on them. Alright, this is fine. So let's check one of the beams that we copied here, like this one. We go to edit member loads, then we see that we have the roof load on it, so that's fine. So we close this. Alright, so now before we do the analysis, let's check our model. Let's do a model check. Let's go to analysis and building analysis. Under this analysis, we go to building model check. So we start. This is where you are going to discover if your model has any error. Okay, good. We have 6 errors. We have column 9647 overlapping with another vertical member in lower story. 9617, 9648. Okay, let's need to check these columns and ensure all these overlapping problems are resolved. So for instance, this 9C47, we have 9C17 and we have 9C48. Also we have 8C47, we have 8C17 and 8C48. Now this is what we do. We close this first, then we close this. Now let's go to plan. So let's go to story 9, then let's go and look for these columns. Let's go to columns, then let's go for 9C47 first. Right click, go to properties, then you change this length of story to 1. Update, then you close. Again you do for 9C48, go to properties and change the length of story to 1. Update, then you close. Then you go to 9C17, go to the properties, then change the length of story to 1. Update, then you close. Oh, we didn't copy the column that we have here. Oh, we didn't copy the column, so let's go to story 2. Let's copy this column, generate to story 4, story 6, story 8, story 9. Okay, yes, I think we forgot to do that. Alright, so now we can close this. So again, this 9C18, let's go to the properties and change the length of the story to 1. Update, then we close. Now why these columns were actually overlapping with the other columns is because the length of story was 2. Now this is what I mean. Let's go to 3D. Let's take one of the columns as an example. Okay, let's take this as an example. Let's take this 9C47. You know, I changed the length of story to 1 just now. Now let me take it back to 2 and see what is going to happen. You can see it is overlapping with the column underneath. So this is why I changed the length of story to 1. Update. Now let's go and check our model again and make sure we don't have any error in our model. So we go to analysis again, building analysis, go to analysis here, then building model check and start. This is where you check if your model has any error. Alright, so the building model check is completed and our model does not have any error, so we can now close this. Now we can run the analysis. Wow, this is what we have been waiting for, the analysis section. And I just hope you like what you are seeing. If you like what you are seeing, please kindly like the video and subscribe to my YouTube channel. So now let's go and run the analysis. So first of all, we go to building analysis. Then this is where we are going to edit our materials, the concrete, the reinforcement sizes. So let's start with the concrete. So we select here, let's use grade 25/30. 25 there is the cubic strength, and the 30 there is the cylindrical strength. So we apply this to every member, then we okay this. So we have everything changed to 25/30. So the same thing for the reinforcement. We go for, it depends on the strength of your steel. So I want to assume 410 for the purpose of this training, so I will apply this to all the other members. So I will close this. For the columns, I want to assume a diameter of first of all, you unselect, so you have nothing checked here before you now start checking the various sizes that you want. So I'm going to select 16, I will select 20, I will select 25. I think that's okay, so I will click OK. Then for the concrete walls, I'm going to select, unselect, then I'm going to make 10, 12. Okay. For the longitudinal web bar, I'm going to select, unselect, then let's make it 10, 8. Then for the horizontal web bar, select, unselect, then make it 8 and 10 as well. Then for the concrete beams, select, unselect, and make it 16, make it 20, make it 25. Okay. Now for the slabs, let's make it 12. Well, I use 12 for all my slabs, but let's just select 16. Let's see, maybe the ripped floor might want to go for this iron 16, but I doubt. I think 12 should be enough, but let's just select 16. Okay, I think that's oh sorry, I forgot that we have an option for the rip. So let's make the slab, let's make it 12. Then for the rip, we make it 12 and 16. Okay. Now for the links, let's select, unselect, and for the rips, let's use for the links, let's use 10, 8. Okay. So now for the foundation, let's use for the foundation, select, unselect, let's make it 25, 20, 16. Yeah, that's fine. So we click OK. Then for the links, of course, we have 8 and 10 selected. So that's enough for now. So now we go to project parameters. For the project parameters, this is where you see the design code you are using for your analysis and design. Now in this case, for our concrete design, we have the Eurocode 2. So our design is based on Eurocode 2. If you want to change this, then you can change it here, but I'm not changing anything, so I'll leave it as Eurocode 2. Then for the foundation, for the bearing capacity of our soil, I'm going to assume a value of 150. Then for the lateral loading, I'm going to leave this as default, and don't forget to apply notional loads at the story levels. The notional loads take care of any irregularities in your form work while trying to erect your columns and your the other vertical members, like the wall, the lift shaft. So now I will leave this as default. Then I will go to lateral drift. I will make this wall braced both directions. Then for the title of the project header, I will say this is a proposed commercial development. Alright, so made by, you can just put your name, engineer Michael, then checked by engineer, I put my surname, then the project number, I don't know, it depends on you, 2022. Then the project date, I put today's date. Alright, so okay, now the loading combinations, this is where you generate different loading combinations for your analysis. I will leave everything here as default. Actually, there is a whole lot you can alter, there's a whole lot you can modify, but for the purpose of this training, I'm just going to touch the basic settings. So we go to horizontal load combinations. I'm going to check wind loading. Of course, the notional loading has been selected earlier, so that is where we have it checked by default. So I will click OK. Then all the loading combinations are going to be generated. If you like, you can delete a loading combination. Like if I select this now, I can just delete it. If I don't want, I can like this. So it depends on you. So I'm going to just do it again. Then I have the 15 loading combinations again. So okay, so now for the wind and story loads, I'm going to go to the wind load calculator. Then I will change the basic wind speed. It depends on the value you have, so I will make it 15. This is an assumption, so don't forget to get a verified an authentic value for your basic wind speed when you want to do your analysis, so you can have a good analysis. Don't just assume values, try and get the real values for your analysis. So I'm using 15. Then I will click on apply. Then if you expand all the stories, you will see that automatically the wind loads, the wind forces have been generated, both the X direction and the Y direction for all the stories. So I'll click OK. So from here I will go to the model options. I usually use this. Then here I will use the finite element shell. You can change the shell sizes here if you want. The larger the size, the faster the analysis, and the lesser the sizes, the slower the analysis. So for the slab model, I will leave it as slabs to define a rigid diaphragm. Then if you want to include the slabs in your building model, you can include them by selecting this, and you go to stories to be meshed. Maybe you go to story 1, 2, 3, 4, 5, 6, 7, 8. We don't have any slab in story 9, so I'll just stop here. Then for the settings, I will use the composed beam loads. Then let's go for the analysis, but now we're not going to analyze yet. We just close this for now. Then we go to loading. Then under loading, let's go to the load combination, decomposition by finite element. All right, it's the training is becoming more interesting now. We are going into the analysis, and from the analysis we go into the design. So now from here we go to the finite element beam load decomposition. That's all the stories. Then you click OK, continue, and automatically we have the load decomposition running by default automatically. So you can see it's moving from a higher story to a lower story. You can see now we are at story 8 now. It's going to move from story 8 to story 7 to 6 to 5 till we get to story 1. Now we have a warning here: beams and all slabs have been detected at this level, that is story 7, that do not lie in the floor plane. You know why? We have the what is it called, the staircase at this story 7, and the staircase is, the panels in the staircase is not in a horizontal form. It's slanting. Those panels are actually slanting, and that's why we have this warning. So don't worry about this, just click yes. Like portal structure is asking, do you want to continue? So just click yes. It's because of the slanting panels in the various staircases. That's why. So now we are at story 6 now. So again you click yes. It's because of the slanting panels. So when you see that kind of warning, you just click yes. We're at story 4 now. Story 4 is our second floor. Story 2 is the first floor. Don't forget, story 1 is the mid-story between the first floor and the ground floor. Story 3 is the mid-story between the first floor and the second floor. Click yes. So we are heading to story 2 now. That is the first floor. We're at story 2 now. So we'll be going to story 1 now. Alright, we are story 1 now, and that's the final level. So after the composition, you're going to have this message. Then you click OK. So you close. After clicking the close, you go to apply all beams in the model. Yeah, so we are almost done with the analysis. Now we go to analysis, go to building analysis, then you go to analysis, then you go to building analysis. Now you see it's showing this sign because we have not actually analyzed the model. After the analysis, it's going to tick it, it's going to mark it to show that the model has been analyzed. So now I don't want to design the beam, I don't want to perform the beam reinforcement design now, and I don't want the column or wall reinforcement design. I just want to analyze the model. So I'm not going to check this, I will just go to building analysis, since I'm not ready to design the columns, the walls, the beams for now. So what I'm doing now is analysis, not design. I want to see how the analysis would go first, then later on I will come back to design. It's always good to check your model in case there is any error in your model, so as to avoid problems in your analysis, because once your model is wrong, then your analysis cannot be correct. When your model is wrong, the analysis can never be correct. So it's always good to check your model and to make sure that your model is actually free from errors. While running your analysis, you would also know if your model has a problem. It will bring out some kind of kind of warnings, kind of errors. So if your analysis goes smoothly, this is to tell you that your model is okay. Alright, okay, now I have axial load comparison warnings. Difference between the building analysis result and the decomposed beam loads is 5.67. well, this percentage is, I'm not bothered about this because it's not that much anyway, but it's always good to have something around maybe 4.32%. Probably by the time you run your own analysis, probably it might not bring out it, but this is not a problem anyway. This is just telling us that the difference between the building analysis result and the decomposed beam loads is 5.67%. Anyway, it's not a problem. Just click OK and you see building analysis completed successfully, and the relative Storey drift satisfies the limit. This is very important. Make sure you have this ticked, or else there might be a problem with your model. So this is these two directions satisfies the relative Storey drift limit. So now we click OK, close. Also, we can go to the post analysis, and then you can go to display the analytical model. Then this is the analytical model. So you can see the behavior of the model under different loading combinations. You can see the behavior of the model under different loading combinations. When you go to displacement and you go to animation, you can check the behavior of your model under different loading combinations. These are the loading combinations, and you can, and if you like, if you don't want to see all the stories, you can just uncheck all stories and maybe possibly go to maybe story 2. You can see the behavior of your model. Can you see under these loading combinations? You can see this is how the slabs are going to be acting under this loading combination. You can see they are going up, down, like that. Then also there is another thing you need to check here. You have the displacement. Under this loading combination, we have the maximum displacement to be 0.019183, and we have the minimum to be this. So these are, you can check a whole lot of things under the analytical model. And also, if you don't want to check for all the axes, maybe you just want to check for maybe let's say I want to go for, let me uncheck all the axes. Maybe I just want to go for axis A, for instance, or only axis B. So you can actually do a whole lot under these settings. All axes. So you can right click to rotate your model, and you can zoom. Alright, so now I'm going to stop the animation now. Then I'm going to close this analytical model, model 2, model 1. Now we have come to the end of this episode. We have been able to analyze this whole model, and in the next episode we are going to be running the design for the beams, design for the slabs, design for the columns. Thank you very much. If you like the video, please don't forget to subscribe and like all the videos on my channel. Thank you very much, and see you in the next episode. Bye.